Hello everyone, this is Nader Sharari. In this video, I will be presenting Teach 1 by going over the multi-level regression. So as a specific, I'm focusing on question 3 in week 3 assignment. An overview of what is multi-level regression. Multi-level regression allows us to examine the relationship between variables on 2 or more levels. Reduction of system with multiple independent variables. Also, multiple regression is specifically designed to create regression on a model with single dependent variable and multiple independent variable. So in this case, or in this frame, we will work with intercept regression. For question 3 here, which is using multiple level modeling, calculate the expected length of stay for the clinical and peer group after removing the effect of previous MI and CHF. Then we will compare the performance of the clinical to the peer provider using the intercept estimated for each group. So here you can see the data set on the left side, clinical patient, and on the right side, peer provider patient, where both data shows the case number of previous MI and CHF, as well as the length of stay for each cases. Our aim is to analyze the effect of the two different groups on the length of stay. So multi-level regression is the right analysis to do because it allows us to predict the system with multiple independent variables. So in this case, at the clinical and peer group, as well as with the two prediction, MI and CHF on the length of stay. So in this step, I will walk through preparing the data before moving for the data analysis in R. So I used Excel, replace no with 0 and 1 with yes. So to do that, I went through 3 steps. First, I placed new column C, as you can see. Then I used the if function to replace no with 0 and 1 with yes. Then after that, as you see in the function, if the content of the cell B2 equal to MI, the first argument print 1 if true and print 0 if false. Then at the last step, I run the function through all of column C. So the same step I will follow for the CHF as well. From creating new column, column E, using the if function and running it through the whole E column. So this step we need to do for the both data set, the clinical and peer provider patient. After taking the proper information from column B of the clinical patient data set, as we transfer it into column C, we can delete or hide column B and D, same as well with peer provider patient data. So after removing the unneeded columns, the data set can be seen as this. So now we will be able to begin the data analysis utilizing our software. First, I import the data set into R, then make sure to choose yes for the heading. Then we're going to run the model for the both data set, clinical and peer provider patient. So first, I created a model 1, which represents clinical patient. To create the model, I used the GLM function, which is used to fit generalized linear model. Then for the clinical patient, length of stay as the dependent variable equal the fourth columns, and the prediction MI and CHF as stated here, column number 2 and number 3. So this is the summary of the model as you see. I use the COEF function in this step, which is extract model coefficient. So for the model 2, which is peer provider patient, I used the same code and the same steps to create model 1. And also finding the intercept for model 2, as you can see here. So the last step is to combine the two intercepts. So the new variable name as center intercept, I used RBIND function to combine both two interception from model 1 and model 2 together and get the result as you see here. So after removing the effect of MI and CHF, the expected length of stay for both clinical and peer provider patient is 3. So in conclusion, looking at the length of stay of both the clinical patient and the provider patient, there appears to be no significant difference for the length of stay for both group of the patient. So I think further analysis can be done of efficient data is a provider in order to have more and accurate result. Thank you.